Hi all, welcome to our series of videos on BioRT HBV model. I am Kyle and in this video I'll be talking about generating hydrological input files required for running BioRT HBV model. I'll start by giving an overview of the video. First, we will look into how to install HBV Lite model. Next, how to prepare the input files required. Then we will set up the model and finally run the model and look at the output files. HBV Lite is a popular hydrological model that has been used in over 30 countries. Despite its simple structure, it has been able to simulate hydrology in a wide variety of catchments. Therefore, in BioRT HBV model, we will be using this HBV Lite model to simulate the hydrology and create hydrological files. In order to download the model, you have to go to this website. This website has some information on the model in general. And you can also find some other resources that can help you to learn more about this model. In order to download the model, you have to click on the link here, and it will take you to the download page. Here you can download the HBV Lite model itself. This is a password protected folder, and in order to get password, you have to fill this form here and submit it. Once you submit it, you will receive an email giving you the password. Use the password to extract the files and install the model using the setup file. Once we install the model, we need to then prepare the input files. PTQ and evap files are the two most important input files for the HBV Lite model. PTQ file has information on precipitation, temperature, and discharge, whereas evap file has potential evapotranspiration data. In this video, we will use Sleepers River as an example catchment, and now we will look at the input files for the Sleepers River in particular. So if you look at the PTQ file here, it has two lines at the top, and these are kind of dummy lines, and the model will not read it. For our convenience, we use the first line to denote the catchment name and the second line to show the variable names. The variables are date, precipitation, temperature, and observed discharge data. Make sure that this order is followed correctly. Also, notice the date format here, which is year, month, date. So this date format should also be correctly followed. Since precipitation and temperature are forcing data, these variables should not have any missing values. However, the observed discharge data can contain missing values, and you can use any negative numbers like -9 or -99 to denote the missing values, and the model will automatically consider them as missing. Going to the evaporation file, we can see that there is one dummy line here, and we have used it to show the variable name. You can also notice that there are no dates in this file, which is because the lines in this evap file corresponds to exactly the lines in PTQ file. So however many lines of data are in PTQ file, evap file should also have that many lines of data. Once you have these two files ready for your site, then you must create a folder named after your catchment, and then create a folder known as data inside it. Paste the evap and PTQ files into this data folder, and then we are ready to run the model itself. Before opening the interface, I want to talk about the settings that we need to make in it. So there are mainly two types of recipes we have to make: model settings and catchment settings. In model settings, you have to make sure that the research files are saved, because in HBV Lite, the research files are not saved unless you tell the model explicitly to do so. So these are the particular uh, choices you have to make here. And then also make sure that the model structure chosen is standard version that use the L and K naught in the upper zone box. And also that the basic, and you select the basic model here. And this green box here shows where you have to make the choices about the simulation period and the warming periods. Coming to the catchment setting, HBV Lite model can stimulate different vegetation elevation zones in its subcatchment. However, currently the BioRT model can only simulate one zone. Therefore, we are going to keep the number of elevation zones and vegetation zones as one. So now I'm going to go into the HBV Lite model interface itself and show you how to make these settings. So going to the HBV Lite model itself. So the first time you open this software, it will give you an option, a dialog box like this. Click on the browse for catchments and then OK. Now navigate to the folder where you have saved the your input files. Sleepers River, and I'm going to click on OK. And you can see that this Sleepers River catchment data has been loaded into the model. So now go to settings, click on model settings. As we saw earlier, make the choices to save results, and then make sure the model structure is correctly selected. And then you can change the simulation period. For this video, I'm going to simulate 2014 year. I'll choose January 1 and December 31st here. And I'm going to use a warm-up period of 6 months. July 1. Okay. So I have made the settings for the models. I'm going to go to the catchment settings now. And you can see that I'm not making any changes because we will only simulate one elevation zone and vegetation zone here. So I'm just making sure it's all correct here. It's correct, therefore click on OK. And now you have to run it. So you can look at the model discharge in here, and you can now look here to see how well the model is simulating the hydrology. And you can see that the efficiency is kind of low here, 0.24. So, but in order to improve the efficiency, what you can do is like change the parameters. For example, I'm changing the parameter known as PP here and running the model, and you can see that the model fit has improved and the NFE or the efficiency value has also increased by some amount. So by changing these parameters, you can improve the model performance. This is known as calibrating, and I'm not going into more detail on it, but you can find some resources on these on how to calibrate it in the website that I showed earlier. And also you can go to the help page here and can find a lot of information in general about this model and how to run it, how to calibrate it, etc. So now after calibrating the model, what you should do is save the parameters here. For example, here I'm going to save it as calibrated parameters and save it. I have not calibrated here, but I'm just showing the how to save the parameter file once you calibrate it. So we saved this file in order to make sure that that it is handy to be used in our BioRT HBV model later. So now that we have saved the parameter files, I'm now going to show you the output files. So there are two output files for this model. And they are results file and summary file. In results file, you can find the simulated hydrological variables, including actual evapotranspiration, simulated discharge components, recharge, soil moisture, etc. And in summary file, you can find how good the model is fitting the data, how good the model fits to the data. So here you can find some model metrics like model efficiency, which is Nash-Sutcliffe efficiency, Kling-Gupta efficiency, etc. You can go to the help page on the model interface to get more information on what in particular each of these entries mean. So now I'm going to show you how to find the output files in your system. For this, go to the data folder here. So you might be shocked to find some two extra files, Clary and simulation. Simply the files that were saved when we made the choices on model settings and catchment settings. So you don't have to worry about that. So once you are here, navigate to the Sleepers River folder and then select results, and then you can find the results here. So here is the results file, and you can find the hydrological information here. Similarly, you can also open the summary file and look at the information. So we are coming to the end of our video now. Today we looked into how to create hydrological input files for our BioRT HBV model. I hope I was clear. If not, please do refer to the sources that I talked about, which I will also be showing in the description below the video. And thank you.